Morning all. 5 waiting. Who have we got here? Oh, just Joseph's link has just come in. Let's see. Alistair, how are you doing? We'll be factoring in the impact of social distancing measures on the spread rate of the virus. Okay, well, that can be... Let's see, how would we do that? The simplest way of covering that is to dynamically change the radius of infection. Because we can't... because of the way... I'll just put up the... I'm going to pull up the... This is the original one we wrote. Now, social distancing is going to be tricky in this because there are no houses, no roads, nothing like that. So the only real way we can implement social distancing in this is by reducing radius, the radius of infection. So I think what we're going to do is we're going to... Video really shows out that how many times you actually touch yourself. If we dynamically change things over time, so we say, for example, in step 100, social distancing happens, then what we can do is at step 100, we reduce the radius at which infection can happen. And that would have the effect of, let's say, doubling or tripling or whatever, the distance between people. You know, it's virtual, but it would probably work the same way. Okay, so 12 o'clock, I'm going to start. So I'm starting off with an empty page. Now, I'm basically going to be rebuilding what we had from last week, but I'm going to make it a little bit more dynamic so we can change things on the fly. So, let's see. So I'm on my web server. Now, we can talk about creating web servers some other time. I'm on my web server. I've created a new directory called pandemic. You can see here, pandemic, and there's nothing in it. Nothing at all in it. So I'm going to create a file called index.html. And we'll just create some very, very basic HTML in there. So doc-type HTML, which should have an exclamation mark at the beginning to show that it's a comment. And we'll just make it into a valid HTML file before we do anything else. So we've got a valid HTML file which should be completely empty with just the title, Pandemic Simulation. Okay. Now, the last time that we built this, I built it where each population entity, each person, population entity, sure, why not? Each person was represented by a div, which is a HTML element. Instead, this time I'm going to use canvas. But we'll start off, let's see, we'll start off with the, so we'll create a canvas. And I'm going to give it a small width of, let's say, 500 and a height of 500. And I'm going to duplicate that in the style as well. It's something weird about the canvas element. The canvas element, you can have a different width than what says in the style, and the point sizes within the canvas will react differently. That should be height. Okay. Now, I'm going to give it a border so we can see straight off how big this thing is. Black 000. Reload. Okay, so we've got this space here, and the controls I'm going to start putting over here. So I'll want a reset button so that it just basically starts everything again, and we'll start with that, and then population density. Okay, so I'm going to add in an input, well, let's see, label, population, no, don't know what I'm doing here, button ID equals reset, or restart really, because reset implies that you're resetting the input boxes as well. Okay. And we'll set a break line after that, and then input, and I'll put a label around that. ID equals density. So this will be the density per 10 pixels squared, let's say. Or per pixel, density per pixel. So how many people are there per pixel? Which obviously can't be, well, it shouldn't be any more than one. Otherwise people are basically standing on top of each other. Input ID equals density. Type equals number. Let's say 0.02 to start with. Label. Okay, how does that look? And it did nothing. Why did it do nothing? Oh, because I forgot. This is not closing the canvas. There we are. Now it's closing the canvas. Right. Now, I'll make this float left so that these go up on the top here. That's better. Better-ish. Okay, okay, just to make it a little bit easier to read, put the population density stuff above that. In China, the density would be very high. Yes, but it wouldn't be 1 person per foot squared. So yes, we can work on that. So that's why we have it as an input. So you can change that if you want and see what it's like. So again, I've got this as pixels because this it's completely virtual. But you can change this. You can figure out for yourself what does this actually mean in reality. Okay, how does that look? That's easier. Okay, population density per pixel. So first thing we'll do is make that work. So we want to have a little script here. Okay, and I'm going to link in jQuery because it's very useful for working with DOM elements. So I'll just grab a copy of that, code.jquery.com. Minified, yes, gimme. And I have to change HTTP to HTTPS. Okay. Now, in the script, what we're going to do is add, we'll say that when the page is loaded, which is basically what that means. Well, I'll write it out easier, sorry. All right. Body onload equals init. Okay. We'll create a function called init. It's a bit easier to understand, I suppose. Okay, so when we're initializing, what we want to do is get the information about, let's say, the density there. So we're going to make some global variables. Population density equals 0. Don't need to give them values yet. All right, and now I'm actually copying the variables from the last one as well because, you know, why work it all out again? So we've got the size width and the size height. So population density is equal to what do we call it? Density. Yep. Density dot val. Now, what is this? So what we're doing is we're going to fill. You can think of variables as little buckets of information. What we're doing is filling in this bucket with the value of the density input box, which is that one there. So if we look at the code for that, you can see it has an ID of density. So you represent that as a hash symbol followed by density. So hash density means element with ID density. And we're taking its value. And then this plus here is kind of a quick way of converting a value into a number. It's a trick, really, but it's a quick way of converting a value into a number. All right, so population density. Now, SW equals, and I'm just going to do the same again. We might, in the future, change this so that it can do something else. Let's see, offset width. Now, I'm going to do something else here. I'm just going to subtract 5 from this. And the reason that I'm doing that is that in order to make the dots visible on the page, I'm going to give them a size of 5 pixels. So we don't want the one all the way on the right to be invisible because it's basically half off the canvas. So we're going to have a margin on the right and the bottom of 5 pixels. All right, so that's the initialization. And oh yes, and we'll also want to set up the canvas itself. Let's see. No, we can do that. We can do that elsewhere. Right. We also need the populous array. Now, this will be the array of information about the people that we're going to be simulating here. And so let's start setting that up. Now, first off, I'm going to just set up a little comment block like that. Set up population. And I use this because Vim and some other code editors have the ability to fold code. So you can fold like that to hide the information that you're not really interested in. So that means if you're looking for something very quick way of converting a value into a number. Is a value not the same as a number? No, could be a letter. But also that is not the same as that. Or sorry, that. It's not identical to that. I mean, that is literally a string of 3 characters, while that is a number. That can be represented with 1 byte, but this one can't. So they're not literally the same. This can cause problems if you do something like now, in that case, e is equal to 12. Well, it's actually equal to 1, 2. So what you do is that, if you do that, well then you're pre-converting the 1 into a number 1, and then you're adding on 2. And you're adding on the 2 to a number, so JavaScript will actually convert that into a number as well. We can test that. If I just press F12 here, go into console, 1 plus 2 gives you 1, 2. Now if we do the same but add a plus at the beginning, well then I'm wrong. There. Okay. JavaScript does magic. So in this case, I'm pre-converting 1 and pre-converting 2. So what happened to that one there? Well, that's probably the same as that. So it's actually the other way around. It's converting it into a string so that it works. So yeah, the pre-conversion works. It's just a trick. Right, let's see, setting up population. Right, so first we need the number of people. Pop equals pop density multiplied by SW multiplied by SH. So that should give you a number of people, the number of people in your population. Okay, and now we're going to give them positions and states. So var p is for person. So var p equals x math.random. Now math.random, when it's run, returns a number between 0 and 1. So if we multiply that by the width, then we get a number between 0 and the width. So we'll just multiply that by SW. Y math.random multiplied by SH, sorry. And what else we need? State. State 0. So state is whether somebody is infected or uninfected. Now in the last version we had 3 states. We had 0, which is uninfected, 1, which is infected, and 2, which is dead. We're also going to have in this version 0, 1, and 2 in this case is going to be immune, and then 3 will be dead. So immune means that it's the same as uninfected, but you can't get infected anymore. Yeah, we could make this more complex and add in that you're infected but not showing symptoms, but you know that might be too complex for what I want to accomplish here in 2 hours. So now if, let's say we have, I'm going to add in, yeah, I'll leave it at that for now. I just want to show the information. So after initializing everything, I'm going to run show population. Which I haven't created yet. Let's create that now. In fact, I just want to show things as I go along. So console.log pop r, and I forgot something here. I need to actually stick this p into pop r. Okay, now let's run that. Now I'll have to press F12 again. I'm going to console, and if I run this again, reload, then we have init. I really wanted this to only happen when I press reset or restart. I'll do that in a moment. That's empty. Why is that empty? Huh. Oh, it's because of this. That should be a less than. Nope, that's still not it. I is less than pop plus plus I. What is pop then? Pop is pop density. Console.log pop. Not a number. Brilliant. Right. Okay. It's probably because I combined. Oh, I know what it is. Yes. Okay. When you use jQuery to grab an element, what's actually returned is an array of elements ish. So we need to choose the first in that array to get the offset width and offset height. There we go, that's better. Now, what are you saying? There should be a 0.5, which is asymptomatic but carrier. Again, adding more complexity. We'll do the basics first, and then we can go back in and make it more realistic by adding in bits. Right, so I've got a population, and let's have a look at one of them. I'll open it up. We look at the first. We've got an X position of 476 and a Y position of 356, which would be probably around there or so, and a state of 0. Now, we want to start off by having at least one person infected. So how many? Let's add in another value here. Actually, let's show. Now that we can see that the population has been created, let's show the people. So show population. Let's create the function show population. Is there going to be minorly infected? I'm not sure what you mean by minorly. Explain that. Right, show population. For this, we're going to grab the canvas. Now, I use the dollar symbol in these variables just to signify, just to remind myself really that it's a jQuery element, which might have extra things on it. Right, and then we're going to say that the CTX, I can't remember what that stands for, is equal to context of course. Canvas 0 dot get context to D. It is lowercase. Okay, so what we're doing here is we're getting this, we're grabbing this element here, and we're grabbing the canvas sheet or mode or something like that in it. We're basically reaching into it and saying, I want to edit the graphical content of this element. Not every element has this get context thing. Okay, now I want to first off color it black. So ctx.fill rect 0 0 sw plus 4 sw sh plus 4. So that will paint this black. Okay, so we start off, let's see, like they are only affected by the virus slightly. Right, yeah, the tricky thing there is that then you're saying that some of the population, could be done I suppose, that some of the population acts differently from other parts of the population. I could do that. I could have, let's say in the population here, we could have an immunity factor or something like that. Again, we'll get back to that. That's an interesting idea. I'm not sure how realistic it is in this particular case. But yeah, it's an interesting idea. Like it could be, for example, if cowpox, for example, if somebody's had cowpox, well then they're unlikely to have smallpox. Could you add immune system strength? So the stronger immune system, that's basically what we're talking about here already. We'll get back to this, and yeah, it's an interesting idea, but I don't know how realistic it is. I mean, does it have a strength? Can you have it between a 0 and 100? I don't know. We'll get back to that. Okay, so after painting everything black, I now want to paint the positions of the people. So population R dot for each. And this is a recent addition to JavaScript. Recent as in I'm more than 43 years old, so I don't know, it could be recent in the last 15 years, but it's recent for me. Right, for each of them we want to paint a dot. CTX fill style equals, let's say green for now, or GB 0F0. CTX dot fill rect. So we want it at the position that the person's at in X and Y, and the size of this dot will be 5 by 5. So it adds them on. Now that should paint each of the items in. Let's see. There's our people. So you can see that's pretty dense. The R0 of the coronavirus is between 2 and 2.5. So in your model, each infected individual should infect between 2 and 2.5 other individuals. Okay. The R0 is a meta figure. It comes from the behavior. So it depends on the behavior of the elements. It's not that you can just put in R0 and that is now the correct number. It's actually a result of the behavior of whether people do things. So what we're actually modeling is the behavior itself. What do people do? We can calculate the R0 afterwards from this, but you can't pre-calculate the R0 and then define what the population does. Okay, so if we're displaying the people, yes, that's good. Now, let's add in the infection. So going back, we're going to add on. Now here's where folding comes in, because we've already got more than one page of information. So I'm going to fold that down, and you see what I mean by folding. So let's add in a variable called initial infection, and we'll say it starts off with 3. Okay. So opening up the initializer, and go into the population part. What I want to do now is that if, first off we need to grab that information. Don't need the var, it's already initialized. Inf equals plus at the front of that. Okay, now if I is less than init inf, then we say that p.state equals 1. So it's infected. So we're saying that in the beginning of this we want to have some people infected. So let's say 3 in this case. Now we need to show that. In fact, I'm just going to show population again. So console.log on the pop r. So we can have a look at that again and see what it says this time. Just push that down. Reload. F12. So there's our array of people, and the first 3 have a state of 1, and everyone else has 0. Now we don't see them yet because we haven't told the system to display people differently. So let's paint infected people red. Could be interesting to do that in real life. Don't do that. Don't do that. Okay, let's see. So this is where we're painting each person. I'll just add a comment on that. Draw person. And here's where we're defining that it's green. So let's change that now. So we'll just set up another variable here. Var colors. What did I call it before? I did call it colors. All right, and it's a 0 indexed array. So the first color is going to be healthy, which would be 0F0. That's a green. In fact, it's the green. The second one is going to be infected. So we'll set that to be red. And that's F00. And we'll leave it at that for now. Now, so instead of having it hard coded in here, we're going to use the colors array. And it's going to be p.state. So if p.state is 0, then you get green. And if p.state is 1, then you get red. Okay, let's reload. So we should have, and we don't have, 3 red ones. Where are they? I've obviously made some mistakes somewhere. Yes, the first 3 should be 1. So what mistake did I make? I don't see. Oh, there's a red one. There's 1. So there 2. They're there. They're just hidden. Okay. Just to make it more visible, I'm just going to reduce this density to, let's say, 0.01. Okay, 1, 2, and there should be a third one, 3. So they're there. Yeah, thanks, Evan. They're there, all right. Okay, right. So now that we have infections, we have infected people, I suppose the next thing to say is, how do we actually infect people? So let's say that if somebody is within a certain radius, then they will get infected. Okay? We're going to keep it simple. If somebody is within a certain radius, they will get infected. So we'll call that infection or infection radius, inf_or. Okay. And again, I'm going to make a variable out of this. we can't, the reset button doesn't work yet, but I'll do that in just a couple of minutes. Initial infection size, so infection radius. Let's set it quite large to begin with, so I'll set it to 5. Should be inf_or. Infected with bat soup. Come on. Now, it's actually surprising, but this is not the first disease that started from bats infecting pigs. or from bats. There's another one, there's a previous one that where a bat infected a pig. I don't remember exactly how that happened. Bat droppings, and pigs ate the droppings, something like that. Right, so what are we doing? Infection radius, yes, infection radius. So we just want to fill that in from here. So infection radius equals inf underscore or. That's not an underscore. Dot val. Okay, so before we show the population, we want to run an infection and see what happens. Hello, Bone. Right, so we want to run an infection. Okay, so we can just hide that, we don't need that anymore. So what we're going to do is go right through all of the population, and if they're infected, we're going to check who else is within the same vicinity and infect them as well. So let's see. Right. Right, there's a reason, yes, I spent about 10 minutes figuring this out last time. There's a reason we do this first. I'm going to do it first and then I'll explain it. All right. So we first off do a loop where we're checking each person in the pop R. Okay, and we're grabbing two pieces of information about this. We've got the actual object itself, the person, and we've got the index, which is what part of the array are they in? What's the number of the array that they're in? Okay, now if this person is not infected, then we're not interested in them, so we'll return. Okay. Now, so if we've got to this line, then that means that this person is infected, and now we want to check everyone that's around them. So we'll call this person Q. Person Q. And we'll say if this person is the infected person, because obviously, like, since we're checking the population against the population, for every person that's in there, if we're checking every other person, we're going to match against ourselves every now and then. So we can just ignore ourselves. Oops. But we can also ignore anyone that's already infected, and also anyone that's immune and anyone that's dead. So basically anyone that has a state other than 0. But also, in this case, the person doesn't have, the person's state is not 0 either. So we can just basically say, if Q.state is greater than 0, then return. So if the person you're comparing against is not uninfected, then there's no point even looking at them. The reason I'm doing this is because the bit of maths here that I'm about to do is probably the slowest part in the whole system. It's the reason why the whole thing runs slow. So var d equals math.square root. Now, if you know your math, then you'll recognize this as Pythagoras' theorem. Okay, so what were we doing here? We're looking at a triangle basically. Let's say we have a look at this. We look at two dots. Let's say that dot there and that dot there, and we want to know the distance between them. Okay, now if you just follow the mouse there, I've got a line going straight to them. Now if you also follow straight across and straight up, then you see that makes a triangle. Okay, now if you take that and call it, and take the x squared of that, and then you take this and you can call that y squared, then you know that the distance here is the square root of that plus that, because of Pythagoras' theorem. So that's what this does. We get the square root of the square of the x distance plus the square of the y distance. That should be, yeah, that's right, okay. And now we've got the distance between them. Now, if d is less than infection radius, then they're going to be infected. List to infect dot push QIDX. So they get added to this list that we're going to infect in just a moment. Now, I just want to see this list. List to infect. I want to see this list. Let's have a look at that now. So we'll just clear off this and reload. Oh, I broke it. Mat.pow. Pow is short for power. So we're taking this number and we're putting it to the second power. Okay. So with a radius of 5, we're infecting only one person, which has the index of 1390. So which person would that be? I'm guessing that person there. Right. Now, let's do that. So we're just going to infect them now. So let's to infect, yeah, list to infect dot for each p actually it's an index, so PIDX, let's call it. Pop our PIDX dot state equals 1. So they are now infected. So remember, the initial infection size is 3. So when I reload this, I expect to see probably 4, maybe 5 people infected instead of just 3. Reload. I've got 3 people here, 1, 2, 3, 4, 5, 6 people infected. Shouldn't the dots be moving? I haven't written that bit yet. Remember, I'm building this from scratch. Every piece of code in here is being written from scratch. I'm basically describing the entire thing we built last time, but we're building it. I've just scratched myself again. That's so difficult. Right, so we now have 6 infected people. Okay, but yes, movement is something that we need to simulate later on. In the beginning, but just think of it, I'm just going to actually do something now. The next part is, we've simulated basically one step of this, right? But you see, nothing else is happening right now because it's basically finished. It's done, it's run, it's done. What we want to see now is what happens in the next step. So let's say I run this. It's showing the population. Now let's say we start again. So at the after we're showing the picture, we will set timeout and run the infection again. And let's run it every second. So a set timeout means pause for a moment and then run this and do it in that number of milliseconds. So we're doing run infection in 1000 milliseconds. It's approximate. Set timeout's not great. Let's do that and see what happens. Nothing. The reason nothing happens is because our infection radius is too large, is too small, and everyone else is too far away. So, but that's something to show as well. It's not scratch. This doesn't look like scratch. No, I'm starting from scratch. Sorry, I wish people didn't call that scratch. That language, oh, it's irritating me. I'm starting from scratch, from nothing. Right. Okay, what was I doing? Oh yes. So I could increase the radius or increase the density, population density. I'm going to increase the radius first. So we increase that to, let's increase that to 10. Let's see what happens. So I've doubled the radius. Oh, look. Oh. I'm going to speed that up. So instead of once every second, I'm going to do it once every 10 milliseconds, or 100 milliseconds. There we go, look at that. Now, this is important. Notice that it stopped. The program is still running in the background, but it stopped. It stopped infecting people, and that's because everyone is more than 10 pixels away from an infected person. This is what happens when people self-isolate. If you stay away from an infected person, you don't get infected. Simple. Okay? So this is what happens if nobody's moving in the beginning and there is an infection distance. Okay. If we add in movement, we'll do movement now and see what happens. I'm not talking about dead people yet. I'll talk about that in a while. But for now, let's just see what happens if we do add in movement. Okay. So let's say before infections happen that people move. So we'll say run movements here. And we'll just create that now. Okay. So let's say that everyone moves very, very slightly in a random direction. Now, how did I write this before? Two pixels basically minus distance equals. Oh yes, it was just a random. Yeah, okay. So pop r dot for each could you add a playback speed? Like you could choose how quick the program runs. The playback speed, yes you could. Playback speed would be basically this number down the bottom here, the set timeout. If you change that number, it goes quicker. So we could add a variable in here to change that. Do you know what? Let's make that our first interactive piece. So I'll go back up here first. We'll just pause down on this run movements. Right, that looks okay. It's not going to do anything yet, but I'll make this our first interactive piece. From infection. So right now I've got 100 hard coded. ms for milliseconds. We'll start off with, let's say, 1000 just to keep this slow. Right. Now, I'm just going to put it directly in here. Where it says 100, I'm going to say, we'll call the playback ms. Oh, like that. And we'll just make sure it is a number by adding a plus. Right, let's give this a shot, see what happens. So right now it's got a playback speed of 1000. And now it's 100. But you see, again, like it's not going any further than that because, you know, space. Okay. Right, maybe it'll also show the percentage Oh, that was infected or dead, not affected after it ended. Yeah, actually, well, after it ended, there is no end to this really, but we can show it. We can show the values in here. Now, I'm going to do this and then we'll just get back to the script. All right, so let's add in that. We'll create an element called stats. And it starts off empty. Okay, now, since we're showing the population, we might as well count the population as we're doing it. So we'll say pop stats equals. We'll say uninfected starts at 0. Infected is 1, 0, 0. Of course. All right. We don't even need to do that. I'll do it anyway. All right. Okay. So we'll say. Did it again. If p dot state equals 0, then pop stats dot uninfected plus plus. That adds 1 to it. It's an incrementer. So it adds 1 to the value that's already there. Okay, now let's do it again, but we'll do it for the infected. Okay, so now we've counted the uninfected and we've counted the infected. Now we need to actually show the values. So we'll say that stats.html, and I'm going to push in some HTML into this. So we'll say infected plus pop stats dot infected. Yeah. In fact, I want it to be uninfected first. And a break line between the two. That should do it. Okay, so now I've got some basic statistics going on there, and you have a playback speed. But it's not going any further because people don't move. Okay, let's get back to what I was doing. We'll go back to movements. I'm going to move everyone. So population R dot for each. Right, we're going to start off by saying that people move a random distance of 1. R dist equals 1. But it's a random amount between 0 and 1 pixels. Okay, now I know this looks like a waste to multiply by 1 because what is that? It would just be the original number. You'll see in a moment. It actually does make sense because sometimes, let's see, I'm going to take it out for now. I'll put it back in when I need to. Right, p.x plus equals math.random Oh, I see. Yeah, it's not even needed. Alright, multiply by 2 minus dist. Does that make sense to me? No, it doesn't. Right, let's see. Math.random multiplied by dist multiplied by 2 minus dist. No. Right. Okay. There's a reason I'm confused here. Let me just check on this. That makes sense. So 0.5 minus math.random Yes. All right. Okay. So we want to move somebody in the x direction, but if we just use the mat.random, that gives us a positive number between 0 and 1. But that means that everyone will be moving to the right. But what if we want people to randomly move to the right or the left? Well, that means we need a random number between -1 and 1. So a random number between -1 and 1 is 0.5 minus math.random, which gives you a random number between -5, minus 0.5 and 0.5. And then if you multiply by that by 2, then you get a random number between -1 and 1. There you go. And then multiply by the distance. Now we have it. Okay. Woo! All right, and we'll do the same for y. Okay. Now, if p.x, we don't want people going off the board. So if p.x is less than 0, well then we'll just move them back. The same distance they went off the board, we'll move them back. So that's the multiply by -1. And p.y, same again. So if they go too far up the screen, well then we'll move them down the screen the same distance that they went. Are you going to do where infected people stop moving, as in show that they're self-isolating? That's I want to get to that. So what I want out of this is that first off we show what is it like if the state is the same throughout the whole program, but we also want to be able to say that at a certain time the data changes, right? The values change. So for example, the infection, people stop moving, for example. So what happens if people stop moving at a certain time of the infection? I haven't thought about how I'm going to do that yet, but we'll get to that. P.x is greater than SW. So if or equal to SW. Yeah. So if people are going off the right side, then we want them to come back in. So SW minus P.x minus SW. It's complex looking, but it makes sense if you break it right down. It's not SW, it says H. Okay. And then now that I've changed that person, we're going to put them back in to the array, overwriting the current position. So now we should have our little jiggle. Let's see. I don't see the jiggle. What did I do wrong? I'm always doing something wrong. Alright, well, if I increase that distance, it should make it more obvious if I am wrong. Yeah, nobody's moving. Why is nobody moving? Okay. P.x var p pop.r p idx equals p. What's going on here? We are running the movements, aren't we? Yes, run movements. I'm just going to have a look at the first person in this. Pop r 0 and see if that person's moving. Oh, I see what's going on. All right, see the way it's only run once? That's because at the end of the show population, we're actually jumping straight back to run infection. But run infection is actually the second item that we want to run now. So we actually want run movements first. So let's go back to this and we'll just change this to run movements. It's going to make sense. Now, since I have the distance so large, people are just going to be jumping around. Yes. Okay. Oh, look at that. Yeah. So that's what happens if people move around. Yeah. Okay. Let's change that distance back down to 1. Oh, you can hear my computer starting to whine. Okay, so back at 1, you can see people are still moving, but not quite as much. Now, what that means for the infection is that it takes longer for the infection to take hold. So you saw in the previous one, it was very, very quick. But in this one, you'll see that it's slowed down a lot. Yes, that escalated quickly. It was almost like it was exponential. Yeah. Okay, so what if we reduce the radius now? We'll reduce the radius back down. I had it initially as... Alright, it's 10 at the moment. I'm going to break that down to 5. In fact, let's break it right down. So people have to be literally next to each other, almost literally touching each other before they're infected. And you can see in the beginning 7. So the radius is very, very small. People literally have to be touching, almost touching each other before they get infected. Look at that. Okay. Okay, so that means that in this case we're talking about a virus that isn't airborne, or that doesn't survive on surfaces very long. That basically you almost literally have to be touching somebody and saying, "Here, have this." Slows it down a lot. Right. Okay, let's get to the scary stuff now. Or actually, before we do that, let's do the scary stuff. Let's talk about... No, I'm going to do immunity. So how does immunity work? I don't know. I'm not a doctor, but I'm going to take a guess. I'm going to guess that we can model this as immunity can be modeled in this case as a random chance per step that a person moves from infected state to immune state. Okay, so let's add that in. So we'll say that the chance that somebody becomes immune after being infected is a certain number. So let's add that in. So we'll say let's say that's a value of 0.1. So let's say it's a 1 in 10 chance per turn that somebody that's infected becomes immune to it. That allows us to have the case where somebody can basically be sick one day and healthy the next day, or you could have them sick one day and then they're still sick a year later. Like I tend to get coughs where if I get a flu, then I'm still coughing and sneezing a year later. It's very annoying. In my case, what's happening is that my body is actually overreacting. It's just basically, there's a little bit left there. I'll go keep coughing until I can't even get the smell of it. Right, immune chance. Let's add that in. So run infection is here. So let's add on. After that, we'll add another step, which is run immunity. And it's actually going to be very, very similar-ish to the run infection. No, it's not really. It's not. It's similar-ish in one state, in one way. So this population thing is going to be in this one. And we're going to say at the end of run infection, we'll run immunity. So pop r.for each p. We also need their index. If, before we do that, we get the chance equals, and let's go back up here. What did I call it? I called it immune chance. So var chance equals val. Don't forget the plus at the beginning. Now, so if p.state is equal to 1, so if this person is infected, then we'll do this. If math.random is less than chance, then p.state equals 2. And then we'll just save it back. PIDX equals P. It's really, really that simple. Okay, so what does this do? Annoying. So math.random, as we said, gives us a number between 0 and 1. Now, if we say that the chance that somebody becomes immune is 0.1, what we mean is we're basically talking about 10%. Now, percent is an awkward number to work with in programming because you're talking about something which is 100 high percent, you know, where really the math.random is 1. So when you're talking about a percent, you really want to divide it by 100. So a 10% chance is 0.1 in mathematical terms. Now, could you add a changeable value for distance traveled per turn? Yes. Now that's actually something. Oh, touched myself again. That's something I want to add in because people move random amounts per turn. Now the thing is, if you move everyone the same distance every turn, that's mad. People don't do that. I'll do that after we do this first. Yeah, we'll go back and do that in a moment. So let's say if the random chance is below the immunity chance, then we're going to change somebody from infected to immune. P.state equals 2. So we're also going to need a new color for immune. And I'm going to say white. Let's say. Because it's clear, it's easy to see against the black background. And it's distinct from the other colors. Let's have a check of that now and see what that does. Oh, I broke it. Line 85. PRIDX is equal to P. Oh, it's not PR, it's POPR. Okay. Oh, look, what? What? This guy didn't even get a chance to infect anyone. He's suddenly just immune. Oh no! I think they... alright, okay. We don't seem to have any infected people anymore. Alright, let's just add in how many people are immune in here as well. So, if p.state is equal to 2, okay, and I'm just going to add in this one since I'm here anyway. So we'll say we've got immune 0 and dead 0. Right, we've got infected 4. But because people are not moving around very quickly, they're not really infecting anyone. Oh, infected 3. Wait a minute, where's my... I forgot to add it in here. So let's just make this a bit easier to read because it's getting a bit long. Okay, reload. Alright, so we've got 3 infected, 4 infected. I don't see them. Oh, there they are. Oh, what? We've got some immune people. Now remember, immune people don't spread it on. Unless they're carriers, but we haven't got that simulated. Now, what have we got? Immunity works because the memory B cells and memory T cells remember the virus and can quickly develop antibodies in the event of reinfection. That is true. T cells. Okay, so now we've got full immunity here, 7 people. So that happens because the radius of infection is so small. People aren't really moving around very much. It's not very exciting for this. All right, let's reduce the chance of immunity. Let's bring it down to 1 in 100. Okay, and I want to speed this up. So you can see a little bit of jiggling going on. We've got 3 infected, 2 infected, and 2 immune. Right. Okay, let's increase the radius again. 5. I want to have at least something on screen to look at. Right, 4 infected. I think maybe we'll do the movement now, so people actually start randomly moving a little bit more than just 1 pixels per moment. So that's 4 infected and 1 immune, so that in total was 5. But you can see one thing as well that this shows in is that if people are infected and they can hang on long enough, then they will become immune over time. You know, anyone that's infected, if they're in reality, basically anyone that's infected and gets treatment and is being treated by a doctor and, you know, can get intubated if they're finding it difficult to breathe, if their underlying problems are being addressed as any symptoms pop up. If things are kept stable, if the person is kept stable, then they will survive this, you know. But if people die before they become immune, then obviously they die. So we haven't had let's see, maybe to fix the immune people problem, you can add a minimum amount of turns before they have a chance to get immunity. Yes, could do that. Well, just reducing the chance of immunity has fixed this problem, I think. But I don't know if that's realistic. I don't know how. I mean, it's possible that if a single virus gets into a body, it is possible that it gets met by an immune cell and killed immediately before it even affects somebody. So it's possible that people that are sick are basically people that the chance hasn't hit yet. So it could be that time is not really a factor in this. It really could be just chance. I don't know. But we can see here there's a small pocket of infection down here. Now, to do with the distance, here's an interesting thought. What if one person here got on a bus and went all the way over here? Let's simulate that. So we'll go back to the movements. And we'll say that there is a random chance that, now remember I have this distance here of 1. But let's say there's a random chance that this person is going to take a long trip. Okay. So I'm going to add that in, chance of travel. And we'll say it's 0.01, which is actually quite large. So I'm going to start with the large number first. Right. Let's see. So distance equals 1. So we'll say that if the math.random is less than chance of travel, so chance of travel equals immune chance of val. Okay, so we say if the math.random is less than the chance of travel, then distance is going to be quite large. Let's make it 300. Otherwise, it's going to be 1, which is our usual. Okay. Let's see what this does. Now, I'm just going to increase the speed here. So, 1, 2, 3, 4. Look at this. There are pockets of infection now popping up all over the place. And this is because there is a chance. Look at that. That's incredible. That's incredible. And that's happening because we've let people travel. So another reason why you would, this is another reason to stay at home. Don't get on the bus. Especially don't travel around to places. Don't go visit your friends. Don't go places that you don't need to go. So that's where the random chance is 0.01 chance of travel. So let's bring that right down again. So I'm reducing it now by tenfold. I'll just put it at the same speed. You can see it still happens. Okay. Let's bring it even further down. This is madness. It's gone out of control. Okay, everyone's immune. Come on, everyone's immune. We've still got some infected people, but everyone's immune. Alright. Okay, that's just crazy. That is just crazy. Right. I'm just going to reduce that number right down to the beginning. Right down as far as we can really go. And we still got, why did I make a mistake? Oh yes, that's silly. Let's try that again. That's still, whoa. Oh, yes. I'm reading the wrong thing. I shouldn't be reading immune chance. I should be reading chance of travel. It's always something. I didn't make a mistake. The program made a mistake. Okay. That's a bit better. Now, I still have it at the same speed as before, but you can see there are 1, 2, 3 pockets and nobody's getting infected. Now, what happens if I increase the chance of travel? You can see the pockets start appearing. So if we let people travel, then the infection starts spreading. So we'll just reduce the chance that people can travel, and that should help people become immune. What have we got here? That's why we need travel bans at airports. Yep. There's not enough dying here for my liking. Too many survivors and happy people. That's true. Okay, let's do that. Yeah. Evan. Okay. Right. So run infections, run immunity. So we'll say that after run immunity, we'll run deaths. Okay. Okay. Did it again. Right. So again, we'll add in a chance here. A chance. So where's immune? There's immunity chance and death chance. Now, here's something where we do actually have figures. Immune chance, so we'll call this death chance. Because if you look at the world, what is it? Worldometers.info coronavirus. Right, I'll just open that up here. Okay. Now, this is the worldometer.info website, which is tracking all these things. And you can ignore this cases bit. I think if we just keep track of this, deaths and recovered, then we can say that once somebody's infected, what is the chance that they will die or the chance that they will recover? And we can say that it's related to each other there. So we'll say of closed cases, there's 11% chance of death. Now, that's not 11% chance per turn, you know, because, you know, in reality we don't have turns. We just have, did you die, did you get immune? So let's just put in, we'll put in a number which is lower than the immunity number. So it looks like 9 times lower. So we'll say that this is that. So it's 1 in 1,000 chance, let's say. I don't know how realistic this is. Chance of dying is lower than the chance of becoming immune. Death chance. I did call it the right thing this time. Okay. And it's actually very similar to immunity. So what I'm going to do is copy the immunity code. And just change things. So chance equals death chance. Now, if the person is infected, then if the chance, yes, then dead. Okay, and then we'll just add in a color here. Can't use black because that's the background color. So let's use a dark red or GB. So let's say 300. That'll be a very dark red. And this should just work. Oh yes. Yeah, you'll see something strange now if I do this. Reload. Stop disproving my messages. Sorry. Function statements require a... I cannot read that. I'm in the way. A function name. 94. Oh yes, of course you do. On deaths, yes. Okay. Reload. Right, now. So we got some movement going on here. 11 infected people. What? Oh, we've got a dead one. Where's the dead one? It's very hard to see the dead person. Huh. I don't know. Let's change it from red to blue. Eight dead people. Does that look? That looks about right, doesn't it? Like 9 dead people, 73 immune. Yeah. Okay, let's change that RGB. Change it to a dark blue. No, I'll leave it as a bright blue. Right, let's have a look now. Playback speed. We've no deaths. 1 death. Oh, there we are. Oh, the dead walk. Look at the dead people walking. Dead people are not supposed to walk. So I need to add in that if you're dead, you can't walk. So that would be under run movements. If p.state is equal to, what is dead? Tree? Tree. Then return. So now we'll have dead people that don't run around. Okay, let's make that faster. So now there's a dead person just lying on the ground. Alright, so we end up with 5. We see mostly the immune people. That's it basically after running its course. Once you're immune, everyone else is safe. That's why vaccines are important. If you are immune to something, then it doesn't matter if there's an infection. If you're immune to it, you won't pass it on to somebody else. Okay, So we've got 95 people immune and 6 people dead and no one infected. Right. I'm going to add in this restart button here. Make that work. What, we got zombies, yes. What color are the dead people? Well, blue right now. I think I saw a dead person moving. Yes, he did. They're not supposed to. I'm too young to have a corona. Yes. Welcome to the, unless you've got a light shining behind you, in which case you've got a corona. Welcome to the apocalypse. Prepare for creative mode. Everyone gangsta. I don't know what that means. Dead people moving. It's uncanny. It's the uncanny valley. Right. Let's see. I want to make this button work. So let's see. What does that actually do? We'll say that when that button is clicked, what's it called? I think I called it just restart. Where is it? It's not that. Oh yeah, it's restart. Yeah. So once it's restart, dot click. So this means that when that's clicked, what should happen? Okay. So whatever should happen, I define in here. Let's see. Well, I could just run init again, but the problem with that is that we still have all of this still running. So we need to basically stop that from happening. Stop, otherwise we have two different things running at the same time. We don't want that. So what I'm going to do here is right down the bottom here we have this set timeout. Now we can tell, we can give this a name. So we can say that let's say window dot the run. I'm very great with variable names. Equals set timeout. What we can do is that if this is clicked, well then we clear that timeout. Window dot the run. Now I'm just going to test that. Basically what should happen is that it should stop. Everything should just stop. Right, so we can see it's running. I'll just speed that up a bit. If I click this, I expect that everything will just stop, and it does. So that stops it. And now what we want to do is start it all again. So we just run init again. Okay. So let's give that a shot now. I'll just speed that up a bit. Okay, so now let's say we want to change the population density to be bigger at the beginning. We'll change that to 0.02, let's say, to double it, and click restart. Oh, if anyone wants to try this, I forgot to say this right at the beginning. That address there is completely live. I'm working on this. That is the actual address of this. demo.verns.com/pandemic/ at the end. If you type that into your browser, you can try this out as well. Look at that. That's like what happens when you set fire to a piece of paper. You know, you've got the flame going out, you've got ash in the middle. Isn't that amazing? But remember what you were saying about chance of travel and if we simulate isolation by reducing the infection radius, let's say we do that, less people are going to get infected. Oh, this is for Alexander. You were talking about social isolation earlier on. If you reduce the chance, if you reduce, you know, like stop reaching out and touching people, you know, I know how much you love to hug people. If you stop reaching out and hugging people, well then that basically has the effect of reducing the infection radius. And that means that less people get infected, more people survive. So over here, for example, we've got immune people right next to uninfected people. Not for long, but you know. So that means they had it, but they didn't pass it on. Okay, so we can simulate all this. Could you upload the code somewhere so I can refer to it later? Yeah, it's right there. It's on demo.variance.com/pandemic. I'll add that link to this video. I'll add it right now. All you have to do is right click and where's view source? They don't have view source. All right, Control U will show you. Control U gives you the source, and this is what I'm actually writing right now. Okay, so it's right there. Okay, now I'll just edit that. I'll edit the let's see, there we go. Just put that in. Okay, so I've just added that to the description of the video itself. Okay, and then we truly have an apocalypse on our hands. Well, there's a lot of dead people, 450, but we also have a lot of survivors. Now let's simulate what happens if we change our behavior over time. So let's see. I've got infection radius here. I've got immunity chance here. Now, infection radius, I think I hard-coded that. Did I? INFR. So what I'm going to do is change that so that it actually reads it on the fly. So if I change it in here, it's going to update what's happening. So instead of having INFR here, INFR, I'm just checking to see exactly how many places it's actually read. It's used in run infection and in init, but in init it's not really doing anything other than setting the global value. So what I'll do is I'll just remove that from there, and I'm going to move it over here. So now it reads it on the fly as needed. 1, 2, 3, 4. Yes. So the infection radius can now be changed on the fly. What else do we need? That's it. Everything else is already read on the fly. Okay, let's try that now. So I've got a playback now of once every second. Let's say all right, so now it's 100. What happens if we increase the chance of travel? So I've got 1, 2 pockets of infection, and we're increasing the chance of travel. There's another one there. Oh, yep. Okay, so everyone's getting infected. Let's decrease the chance of them travel. So that's a ban on travel now that I've just imposed. Alexander, did I? Oh, sorry. This is why I try not to call people by their names. I'm just not good at that. The person, you know, the person that's... Alright, okay, so we'll put a ban on travel, and we can see, let's say we reduce the infection radius now, so we reduce that down to 2. And nobody's getting infected now. Look how close they are, and they're not passing it on. So let's just go the other way just to be sure. Oh, no! Back to 2. Yeah. So I suppose what I just simulated there was what happens if you go to church. Let's all shake hands. Pass it on. No, don't do that. Don't do that. Yeah. So this number of deaths now is actually happening because we had that initial phase where everyone's just passing it on. If we didn't do that, if we just stayed in self-isolation and just didn't, cough on people or touch them, see here the deaths have kind of stabilized. It's slowing down. The immunities are going up very quickly. Deaths are going up very slowly. And the infection is going down. That's what happens. Alright. That's an hour and a half. I don't think I'm going to be adding much more into this. I think we're at the stage where this is usable. What do you think? Any questions? Any questions? Give me the questions. There's a bit of a delay in this, so when you write something, I only get the message a couple of moments later. right. No questions yet. Right. Well, I'm going to call this then the end. You can all go and take a break and go down to the garage to get... Oh, hold on. No, you can't do that. Don't do that. Go get yourself a cup of tea or coffee or something. And if you want to read the source of what we just built or copy it for yourself or just play around with it, then it's right there. demo.verance.com/pandemic. Okay. And I have the link in the description of the video as well. If you want to... You might have to reload the page to see it. I don't know if YouTube updates on the fly. When do you think there will be a vaccine for COVID-19? There are already a few vaccines for COVID-19, but they're being put through clinical trials at the moment. We can't just... in fact, the first person to be... there are different levels of clinical trial. I think phase 3, I think, is what they call it when it's human trials. The first person to go into human trials was, I think, about a week ago. It was a pregnant woman. The reason that you don't just take a vaccine and say, well, I think it'll work, let's just jab everyone with it, is because you end up with, if you just give everyone the jab of something and you don't know for sure that this is safe in humans, then you could be causing something that's even worse than COVID-19. There was, for example, something called thalidomide, which is banned now, I believe. Thalidomide is a medication used to treat a number of cancers. Adverse effects. There was a birth defect problem with thalidomide. It was used kind of uses, let's see, first line treatment in multiple myeloma in combination with, all right, there's a history of it being used in order to stop people from getting cancer and other things. But the problem is that it causes birth defects, and I'm talking about serious birth defects, like people being born with half a limb, or or they just can't live. A lot of people were. It's worse than just dying. It's worse. So you can't just... Oh, I actually watched the doc. Yeah. You can't just give somebody a vaccine because you think it's ready. We have to be sure that it's ready. That's why we have a phase 3 test. Just to give you another example of that, about 15 years ago, there was a case in the UK, I think it was the UK, where a phase 3 had to be stopped after only a few days because there were people dying in the test. A phase 3 means it's gone through all the previous tests. It's gone through animal tests. It's gone through predictive modeling. It's gone through testing of checking against the histories of other similar vaccines or medications. It means it's reached a point where we're fairly sure that it works. It's been tested in other animals that are similar to humans, like pigs, for example, have a very similar immune system and very similar intelligence. Don't eat them. They're good, happy people. Leave them alone. But the human body is different enough that you can't be sure that just because it works somewhere else, it's going to work for you as well. So we have to go through phase 3. Didn't Germany get paid to come up with one? No. I think you're talking about the case where Donald Trump... Now, the news is that Donald Trump offered a huge sum of money to a company in Germany, and I've forgotten the name of it, Cure Now or something like that. But they were offered a huge amount of money for a vaccine for the exclusive use of Americans. Now, that's the scary part, exclusive use. Exclusive use means that only Americans can use it. So that means Donald Trump, if the news was true, was basically saying, we want the Americans to survive, we don't care if the rest of the world dies. We don't know if that's absolutely true, though, because later on, some people were saying that, no, that didn't happen. Who's telling the truth? I don't know. Don't eat meat. Don't eat meat. Leave the animals alone. They didn't do anything to you. Leave them alone. Okay, if CoderDojo is cancelled next time, can you make a sequel? What's the sequel? What is the sequel for this? All right, ideas for next week, or 2 weeks' time. Give me ideas. What I was thinking actually is that in 2 weeks, the Monaghan CoderDojo doesn't have a website. So I was thinking that we might make a website. But if you have a better idea, please tell me. You know, either tell me in the comments here, or tell me in an email, or through WhatsApp or whatever. You know. Wait, it's fake news. No, it's not fake news. It might be true, but I don't know. See, the thing about, there's another. I'll give you another example. This one is a fake news one. Okay, I have 2 3D printers just over there. One of them is working, one of them is 90% finished. Now, there is a ventilator machine. There was a ventilator machine in Italy that was missing a piece. There was a piece broken or missing. And they contacted the original manufacturers to ask them, can they deliver a new one out? And the manufacturers said, no, sorry, we can't do that. And so a guy in the hospital who had a 3D printer asked them, well, can you give us the 3D files so we can print it out? And the manufacturer said, no, can't do that either, because that would be us giving you our personal property. You know, that's them basically saying, like, no, we know people are dying, but no, we're not helping you. No. Now, the fake news bit comes in that it was reported in the news that the person was told by the original manufacturer that if they 3D printed a copy of this piece, then they would be sued. You know, that basically the original manufacturer would come after them for patent infringement and would sue them. You know, being sued for saving a life, I'd do it. I would save a life, and, you know, fine, sue me later. I don't care. You know, I saved a life. It's grand. You can sue me all you want. Now, another piece of that was that the original piece was worth $11,000. That it would cost $11,000 for that replacement piece, and that it was 3D printed for the price of $1. Now, that's wrong again for a few reasons. One is that the original piece wasn't actually $11,000. It was reported later on that it was actually on about $150, $160 or so for that piece. But also, 3D printed pieces are very, very cheap. Hold on. Where's the thing gone? There it is. So I just printed this out. This is a mask. Now, the cost for this is probably about 25 cents. The piece that they were talking about is even smaller than that. More options. Zombies. We need more information than that. Different transmission options. Okay, we could enhance this with different transmission options. Now, what we could also do, if you really want, is we could introduce countries. So at the moment we have a big square which is almost like an arena. It's like everyone get in there and we'll see who survives. But if we introduce something like countries, then we end up with something like Plague Incorporated, where you have infection zones and then you've got specific channels of transmission between them. So you have transmission between transmission vectors like boats or airplanes or birds or animals or stuff like that. Maybe buildings, roads, yeah, that's right. Or maybe people would move away from the infected. That's an interesting one. That's actually a programming challenge. That's a difficult one. We can do it next week. I think it'd be an interesting algorithm to write. The difficulty in it is that it's easy enough if you have one person here, one person here. What direction does this person go in order to move away from that one? Well, that's easy. What direction are they in? Now go the other way. But what if you got two? What direction do they go now? Now it's a lot more complex. Or what if they have 1, 2, 3 people around them? What direction does this person go to avoid the other 3? It's an interesting programming challenge. Yeah, we could do that. It's more complex than you might think, though. Maybe make people work on a cure once enough people are infected. Yes, actually, the way you could simulate that is by increasing the immunity chance. You know, if we just, I'm just going to run this again and we'll do that. Restart, and we'll just change the playback speed. Okay, up. I should really probably make people more infectious first, so let's increase that radius to, let's say, 8. Restart. Oh, that's a bit much. All right, immunity chance increase. Time now. Suddenly everyone's immune. Okay, so that's what that's just a 10% immunity chance. So in that, what I basically did was I gave people a 10% chance of becoming immune, which was 100 times larger than their chance of dying. But it suddenly stopped everything. It's not spread anymore. Okay, anyone else? Any other questions? This pause is very hard. It's very hard to have a live conversation with people because of the pause. Hospitals. How would we do that? A hospital, I suppose, we could actually simulate a hospital. A hospital is where you take infected people and you pull them all into the same place. So what we could do if we were setting up zones in the next class is we could say that this zone is a hospital. And if an infected person is found, well, then we could have a chance that, for example, that they are recognized as having COVID-19 or whatever. So in that case, we say that if they are tested, what is the chance that they are tested? And if they are tested, well, then they are moved from there to there. They are moved from where they are to the nearest hospital. Now, there would still be a chance that the infection leaves the hospital, but mostly I think the infection would only happen outside. That would be an interesting one. The work on a vaccine would slow when some of the scientists themselves become infected. Yes. Yes, but that's why the labs generally have very high controls. In fact, the labs have higher controls than some radioactive labs that I know of. There's a person I know that works in radioactive chemistry, and it's weird. Like they work with materials where even the slightest drop of it, or like a spot of it that you can't even see, if that gets near you, if that touches you, you're going to die. You know, he works with this material. And yet, if anyone is infected by coronavirus, then they are not allowed to come to work. You know, even though these guys know how to work with infectious material, dangerous material, they don't want to be around a human because humans are not predictable. Did you have tea? No, I don't drink tea. I drink coffee. 2 coffees, 1 sweetener. And yeah, black. Let's see, maybe, okay, electric boogaloo, I don't know what that is. Maybe you could try and make a cure when the number of cases reaches a certain value. Yeah, in fact, that's something that I didn't really get a chance to do here. So maybe next time what we'll do is we'll add in a timeline. So we'll add in if cases. So if, let's say if the infected is over whatever, then we start, then we increase immunity chance. You know, we can add in if statements and things like that, or we could add in something like that. All right, what about life vitals? So you need water, etc. So you might need to travel to a water dispenser or maybe a food shop, and people need to go there after enough time. Okay, in that case, we're getting a lot more complex because then you're basically turning this into a resource game. You know, and that's a lot more complex. We'll need to basically restart from to build that the fundament for that. We haven't got that in there. Countries, maybe we can put that in, but you know, you're talking about having shops and people going to visit shops and all that. There's a lot more complexity to that than you might think. I looked up boogaloo, it's a type of dance, but oh, is that what he means? Right? Is that what you mean, Evan? Electric boogaloo? I still don't get it. No. Okay. I once drank a liter of tea in a day. Okay. All right. I'm sure you're probably awake all night, running to the toilet. Okay. I'm going to leave it at this. It's 13:45, so that was 1 hour and 45 minutes of a class. And yeah, I'm going to look at these ideas, and if anyone wants to work on anything else for the next class in 2 weeks, well then yeah, we can work on that. Okay, Evan, explain. If anyone wants to work on anything else in 2 weeks, then just give me ideas and we'll do it. Okay, so any ideas, we'll just do it. Other than that, I'm going to look at the ideas that people have said here and maybe reference them in here. I like the idea of moving away from an infected person. That is a complex algorithm to write, but we can do it. Alright, so I'm going to close this off now, and I'll see you in 2 weeks. Bye. How do I turn this off? There it is. Bye. Are you sure you want it? Yes, I'm sure. Bye.